Hi everyone, this is Mrs. Torigno and I'm back again with the Chapter 7 Test Review Part 1. This is the no calculator portion and this is the back side of that paper. So this will cover questions 15 through 20. These are all the equations that you're being asked to solve. And remember that when you're solving equations, your goal is to undo what has been already done to the variable. So for example, in number 15, we want to somehow undo that exponent of 2/3. The best way we've learned so far to get rid of those is to raise to the power of the reciprocal. So I want to raise to the power of 3/2. And that means I have to raise the 9 to the power of 3/2 as well. Now, this will cancel out. And I know that a lot of you see that and think, oh, it cancels out because we're multiplying. That's true, because when you raise a power to a power, you multiply. But over here on the right, remember that you're doing an exponent. That's not multiplication. We're not doing 9 times 3/2. I saw that mistake quite a bit in the last quiz that we took. Now normally you would just type that into your calculator and get an answer. But notice that this is on the no calculator portion of your test review. So we need to know how to do this by hand. So I'm going to take that 9 to the power of 3/2 and break down that exponent. So I'm going to write it as 9 to the 1/2 and then to the power of 3. And remember, I told you anytime you have a fraction for an exponent, you're going to need a factor tree. Now the factor tree for 9 is really short. You may even be able to do it in your head without writing it down. But when I split 9 into 2 equal pieces, I get 3 and 3. So now I'll take that 3 and raise it to the power of the 3 over here. So 3 to the power of 3 is 27. Remember, 3 to the power of 3 is 3 times 3 times 3. So it's not 3 times 3 is 9. Okay? And that means that for my final answer over here, I would say B is equal to 27. Okay? Let's do something similar with number 16. I need to somehow get rid of that 1/4. So I will raise to the power of the reciprocal. The reciprocal of 1/4 is 4/1, otherwise known as just 4. Okay, which means I'm going to raise the -2 to the power of 4 as well. Now this will cancel out here. And here, because this isn't a fraction, I don't need to do a factor tree. I can just do -2 to the power of 4. Remember that that means -2 times -2 times -2 times -2. And when you multiply that out, you should end up with a positive 16. And again, it's positive because you have an even number of negatives here. So your final answer here would be H is equal to 16. Okay. All right, number 17. 17 is just a little bit more complex because again it has a negative fraction there for you to work with. Okay, that's 2 complex tasks in one. So when I raise to the power of the reciprocal here, I need that reciprocal, the 5/2, to also be negative. So I'm going to raise to the power of -5/2 and -5/2 here as well. And I need it to be negative to cancel out with this negative so that both of those cancel out. So now my goal to find my answer is to do 4 to the power of -5/2. So just like I did up in number 15, I'll start by rewriting that exponent. This will be 4 to the power of 1/2 raised to the power of 5 and then raised to the power of -1. I would always put that negative on the outside because we're going to save it for last. And then notice if I were to put those 3 pieces back together, it would give you that -5/2. You always want to check that when you split up that exponent. Make sure that you did it correctly. Now to do 4 to the power of 1/2, we technically need a factor tree, but 4 breaks down to just 2 times 2. So splitting it into 2 equal factors, I end up with 2. And so now I'll do 2 to the power of 5, and then I still have the -1 on the outside. 2 to the power of 5, and I won't write that out right now, but that's 2 times 2 times 2 times 2 times 2. which hopefully you can handle that math mentally, but remember you can take it in chunks if you need to. 2 to the 5th power is 32. And then raising to the power of -1 turns it into a fraction. It makes it 1 over 32. And again, in your directions, I don't want any decimals here, which without using a calculator, it'd be pretty tough to come up with a decimal for that anyway. Okay, hopefully that one made sense. I would say that one's probably one of the more complex ones on this paper. Well, that one and number 18, because they're very similar to one another. So in number 18, I have a power of -3/4 that I'm trying to get rid of. That means I want to raise to the power of -4/3. Don't forget that when the exponent in your problem is negative, you need to use a negative in your reciprocal as well to cancel it out. And then I'll do 27 to the -4/3 as well. This cancels out here. Oh, I forgot to write my answer back up here. Sorry about that. Should be x equals 1 over 32. Okay, back down here. So what I'm really focused on here is trying to calculate 27 to the -4/3, which again means I'll be doing 27 to the 1/3, then to the power of the numerator, which is 4, and then I'll put that -1 on the outside. So 27 to the 1/3, 27 breaks down into 9 times 3, and then 9 breaks down into 3 and 3. So when I break 27 into 3 equal pieces, I end up with just 3. I'll get that so you can see it. There we go. So now I want to do 3 to the 4th power, and then that'll be to the power of -1. Now we talked about this problem specifically in class, this 3 to the 4th power, because remember that means 3 times 3 times 3 times 3. And I know that seems overwhelming for some of you to do in your heads. Okay, so it doesn't hurt to write it down. And truthfully, it sort of is, because 3 times 3 is 9, 9 times 3 is 27, but then many of us probably don't know 27 times 3 off the top of our heads. However, I showed you with this one to do it this way. 3 times 3 is 9, 3 times 3 is 9, and you should know 9 times 9 is 81. So that means here I end up with 81 to the power of -1. And again, just like above, that -1 is going to flip this into a fraction. So it'll mean that my final answer is m equals 1 over 81. Okay. Sorry, I'm turning a little sideways on you. Running out of room on my desk. Okay. Let's take a look at 19 and 20. 19 says n to the 5th equals 32. So we are trying to undo a power of 5. Just like before, I'm going to use the reciprocal. And the power of 5 is just 1/5. Because remember that 5 is really 5 over 1. So that's going to cancel. And I'm going to set about to find out what 32 to the 1/5 power is. Now luckily here, there's no exponent that I need to break up because 1/5 is just a simple fraction. I am going to take that 32 though and make a factor tree. Okay, you'll see from my factor tree that 32 breaks down equally into 5 2's. So that means my answer here is just n equals 2. I don't have that additional step of finding another power. Okay, question 20 is one that sends a lot of students screaming for the hills, and they really shouldn't, because there's nothing new being introduced in number 20. It's just putting a bunch of steps together. It says 2p cubed plus 4 equals 58. Now just keep in mind, you solve this like you would solve any other equation. So if I'm trying to get p by itself, I want to start by subtracting the 4. And I end up with 2p cubed equals 54. Now before we can get rid of that exponent, I need that p to be isolated, which means I need to get rid of this 2. So that means I'll divide by 2. Now this particular division might freak some of you out, because 54 divided by 2 is probably not one that you know off the top of your head. If you can't do that mentally, break it into pieces. I know 54 is really like 50 and 4. So half of 50 is 25. Half of 4 is 2. And 25 and 2 together make 27. That means p cubed is equal to 27. Okay. If you didn't quite catch that, you may want to rewind it again and think your way through it as I describe it. Okay, because you will need to know that type of mental math for your quiz. I'm sorry, for your test. Now to get rid of that power of 3, let's raise to the power of 1/3, which is the reciprocal of 3. So that cancels out. I would need a factor tree for 27. I'm going to notice that I did a factor tree for 27 up above, right here. I already found that 27 to the 1/3 is just 3. So I'm going to use that here. And that's perfectly okay on your test. If you end up making the same factor tree, or a factor tree for the same number over and over again, it's okay for you to just use the old one. Okay, your factor trees will never change. So your final answer here is just p equals 3. Okay. And that's it for the no calculator portion of your test. I hope you found that to be less intimidating than you originally thought that it was. And probably sometime today or tomorrow I will get videos up for the second half of the test review, which covers the rest of the Chapter 7 test. Thanks for watching.